Hey guys, so we're going to be starting on page 22 today. So continuing section 1.5, talking more about electrons in atoms. Today, we're going to go over a little bit about what the atom actually looks like. We sometimes draw it like this with these little orbits, but remember we've learned that that's not actually what the electrons look like. It's actually this like electron cloud thing with these complex shapes. Okay, so this is going to be a longer video, so I'm sorry for those of you who are at home watching this. Maybe pause it and take a break or something. But there's just kind of a lot of information. Also, it's going to be a little more abstract. Like, this isn't going to be any stuff that you've heard of before, and it's going to seem like it's kind of coming out of nowhere. There is a logic to it, so if you listen and pay attention, it'll make sense logically, but it won't be like relatable to other stuff as much as almost everything else we talk about. So sorry, it's going to be a little weird. We're going to start on page 22, and before we get into what the atom looks like, we're going to talk about something called the Heisenberg uncertainty principle, named after a scientist named Heisenberg. And what this says is that it is impossible, we can't know both the location and the velocity of an electron. Okay, and that is because the electron is so small. If we try to figure out how fast it's going, in doing that, we would change its location because it's so small, whatever measurement we make is going to affect it. So, impossible to know both of those things. Because of that, we can't ever know exactly where an electron is. We can only talk about places where it is probable that an electron is. So, we are now going to learn some very, very detailed information about where electrons are in atoms. So the first thing I want to do is I'm going to just come up here in this little space and kind of draw an atom that looks a lot like this one, with 3 circles, 3 energy levels around it. So each of these energy levels we are going to call a principal energy level. So the principal energy level is spelled like this. There are 3 principal energy levels in this atom. There's more in other atoms. We're going to label this one n equals 1. We always label the principal energy levels with n. So n equals 2 and n equals 3. So the principal energy level basically kind of represents the distance from the nucleus. So the higher the principal energy level, the further away we are from the nucleus. So anything n equals 1 is about here, n equals 2, n equals 3. So it's represented by n. Now the principal energy level is also represented by the periodic table. So the first row on the periodic table is n equals 1. This row is n equals 2, n equals 3, etc. Okay, we'll talk more about that later. So these principal energy levels are not as simple as a circle. I know we draw it like a circle, but it's a lot more complicated than that. I'm going to put rho on the periodic table here. Okay, within each principal energy level, there are these things called sublevels. Okay, so there are sublevels within the principal energy level. And there are 4 possible sublevels. So we'll say there are 4 possible. They are S, P, D, and F. Okay, so these are just different kind of energy levels within each principal energy level. We'll draw a diagram that will make this make a lot more sense. Okay, lastly, within these sub-levels, there are these things called orbitals. So rather than like circular orbits, there are these things called orbitals where the electrons can be. So an orbital is a region in space where it is probable to find an electron. Okay, and then each orbital can hold 2 electrons. That's just a rule. Okay, so the different sublevels have different types of orbitals that are like different shapes. So we're going to kind of draw those out. So the S sublevel, so it has S orbitals, and each S sublevel just has 1 S orbital. S orbitals are spherical, so we're going to draw the S orbital like a circle, but really,
Adrian Romero, could you swing by the counseling office, please?
It's spherical like a balloon, and this represents a place where an electron could be. So you want to think about the nucleus being kind of in the middle of this orbital. So like the nucleus would be right here. And then the electron can be anywhere outside that area if it's in an S orbital. Okay. The P sublevel has more than 1 P orbital in it. So we have actually 3 P orbitals. And this is, if I like took 2 balloons and kind of like connected them together like this, that's like a P orbital, except imagine that they're the same size. Okay, that would be what a P orbital would look like. And so the electron can be anywhere up here or anywhere down here, and then the nucleus would be right here in the middle. Okay, so each of these orbitals, remember, can hold 2 electrons. So we could have 2 electrons in here. Now each of these P orbitals can hold 2 electrons. So in total, a P sublevel can hold 6 electrons. Okay, a D sublevel has D orbitals. And some of the D orbitals look different than others, but most of them look like this. So they look kind of like a 4-leaf clover. And D sublevels actually have 5 orbitals. And again, most of them look like this. There's 1 D orbital that looks like kind of like a P orbital with a ring around it. It's very weird. Anyway, each of these can hold 2 electrons. So the D orbital can hold 10 electrons total. So D orbital can hold 10 electrons. D sublevel can hold 10 electrons. The P sublevel can hold 6 electrons. And the S sublevel can hold 2 electrons. And then each individual orbital just holds 2 electrons. Okay? Now I know this is, I said, this is going to be really weird and abstract. Now what's nice is that the periodic table has all this information on it, believe it or not. So there's different sections of the periodic table, and if you were in class today, I would hand one of these out to you, and we would color it. If you're at home, you can feel free to print one of these out and color it. It's very helpful. If you want to just wait until you get back to class, I can give you one as well. So these 2 columns right here, this is called the S block, So we colored that blue, and helium over here is actually part of the S block. You'll notice each row of the S block has two boxes, and that represents electrons. So remember how the S sublevels just have one orbital that can hold two electrons? Here's our two electrons, 1, 2. Each element kind of represents an electron. This red-orange section is the P sublevel. You notice each row, each P sublevel has 1, 2, 3, 4, 5, 6 boxes. See how the P orbitals can hold 6 electrons? 2 electrons per orbital. So there's an orbital, 1, 2. There's an orbital, 3, 4. There's an orbital, 5, 6. Okay? And then I'm labeling all of these with the row that they're in. So 1s is in the first row, 2s is in the second row, 2p is in the second row. Then we go down to 3s and 3p. Now this green section is called the D block. And remember the D sublevel can hold 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why there's 10 boxes there. 5 orbitals, 10 electrons, because again, each orbital holds 2 electrons. And then there are such things as F orbitals. I didn't draw them because I didn't really have room, and also they're kind of like weird to draw. But the F block is these 2 blocks down here on the periodic table, and it can actually hold 14 electrons. In case you're curious, the F block actually fits kind of in the middle of the periodic table. Technically, this is what it should look like. But it would take up a lot of paper, a lot of space to draw it like that. So instead, we take this whole section and put it down here, even though it belongs right here. Kind of like how we take Alaska and Hawaii and just kind of like put them at the bottom of the map, even though they belong somewhere else when we do a world map. Okay, so we're going to come back to the periodic table in a second, because you need to be able to do these things called electron configurations, which explain exactly where every electron in the atom is. But before we do that, I want to turn the page and kind of draw another analogy for this whole system, because I know it's confusing. So hopefully this can help you out a little bit. Okay, so we are going to imagine the atom as if it were a hotel. So we're going to draw a very like rectangular looking hotel. We're going to take up not the whole page because I'm going to write some other stuff below it, but most of the page. I know this says chapter 2, but there's no more room on 1.5, so we're just going to use this page. It'll be fine. Okay, so this is the atom, and the atom is where the electrons live. So this is like a hotel for electrons. This particular hotel is going to have 4 floors. Okay, so each of the floors represents the principal energy levels. And again, remember, the principal energy levels are the circles around the nucleus. So n equals 1, n equals 2, n equals 3. Of course, they're not really just circles around the nucleus. They're much more complicated. That's what we're going to draw in this hotel. So this is n equals 1, n equals 2, n equals 3, and n equals 4. This is the principal energy level. Okay, so the first principal energy level just has one room, and that room is a 1s room. So it's an S sublevel. Now we know from before that an S sublevel just has one orbital. Okay, we're gonna say the orbitals are like beds in a hotel room. So here's our one orbital, and each orbital can hold 2 electrons, right? In diagrams like this, we often draw electrons as little like half arrows. So here's 2 electrons in our 1s orbital. Okay, the second principal energy level actually has two rooms. It's got a 2s and a 2p. And you'll notice this goes along with the periodic table. The first principal energy level just has 1s. The second principal energy level is going to have 2s and 2p. So the 2s room is just going to have one bed. The 2p room, since there's always 3 p orbitals together, remember, they come in threes, is going to have 3 beds. So this room could hold 2 electrons. This room can hold 6 electrons, 2 per bed. Okay, you can see a pattern here, right? Maybe you can guess that the n equals 3 level, we're going to divide up into 3 rooms. So we've got a 3s, a 3p, and this time we're adding on a 3d. And we've got 1 orbital or bed, 3 orbitals or beds for p, and 5 orbitals or beds for d. These are all places the electron can be. Okay, lastly, you can probably guess the 4th floor, or the 4th principal energy level. We're going to divide it up into 4 rooms. So we've got 4s, 4p, 4d, and 4f. So 1, 3 orbitals, 5 orbitals, and this f is going to have 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now, there's a rule that electrons always fill the lowest energy level first. So if I wanted to put some more electrons in here, I'm not just going to go up here and stick them in 4D. That's like really high energy. Remember how the electrons don't like to be at a high energy? Now if we gave them energy and they got excited, they might go up to 4D, but then they're going to fall back down. And they're going to fall back down probably to 2s. So they'd go in 2s, and then if we wanted to put more in, we'd put them in 2p. They always like to go in separate orbitals first if possible, and then if we need to fill it more, they will share the orbitals. Okay. The drawing the arrow up and down has something to do with spin. We're not going to talk about it, but electrons can have an up spin and a down spin. Don't worry too much about that. That's just how we draw them. Okay, so let me show you some questions that you might have to answer about this, and then we're going to go on to electron configuration. You guys are doing really good. I know this is a really long video, and I'm sorry you have to miss class today, but you can do this. Okay, so you'll have questions like, how many orbitals are allowed in an F sublevel? Okay, so if we look at our 4f sublevel, how many orbitals? Well, 1, 2, 3, 4, 5, 6, 7. So the answer to this question would be 7. Okay, what is the maximum number of electrons, that can occupy the second principal energy level? So if we look at our second principal energy level, which is this whole floor, the maximum number of electrons would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4 orbitals in that energy level and 8 electrons total. How many orbitals are in an S sublevel? That would be 1. Okay, I could also ask you how many sublevels are in the third principal energy level. So the third principal energy level has 1, 2, 3 sublevels, an S, a P, and a D. So you need to be able to answer those kinds of questions. Okay. Now, and again, this is just an analogy. Like, the atom does not look like a hotel. I hope you understand that. This is just to kind of help you have some sort of framework to understand these energy levels. The higher up we go in the hotel, the higher energy. I've made some simplifications here. This isn't exactly accurate, but it is accurate enough to help you understand. Okay, so you need to be able to do these things called electron configurations. So the way electron configurations work, I'm going to write them down here. Basically, in an electron configuration, you are trying to give the address for every single electron in an element. So you can use the periodic table to do this. Makes it really easy. Let's start with hydrogen. So the way you do an electron configuration, you find the element, and then you have to account for every single electron. Remember, the number of electrons in hydrogen is going to be the same as the atomic number up here, as long as it's neutral. So hydrogen is going to have 1 electron, and since hydrogen is in the 1s sub-level, 1s orbital, it's going to have that electron in the 1s. So we're going to write 1s, and since it has 1 electron, we're going to write a superscript, which is a little number up to the right, of 1 to show that we have just 1 electron in the 1s. Okay, let's do an electron configuration for helium. Helium's over here, so it's going to have that same first electron as hydrogen, but it's going to have another electron. Helium's still in 1s, so it's going to be 1s2. So literally when you do this, all you're going to do is find the element on the periodic table and account for every single box up to that element. That will tell you where all the electrons are. So let's try lithium. Lithium is right here. So it's going to have 1s2, and then it's going to have an electron in the 2s sublevel. So 1s2, 2s1. So those are the 3 electrons in lithium. The first 2 are the hydrogen and helium electrons, and then it's got a 2s electron. Okay, you can see this pattern. So if I did beryllium, which is right next to lithium, it would be 1s2, 2s2. All right, let's go a little bit further. Let's do oxygen. So oxygen is right here. It's in the 2p section. So oxygen is going to have the same as beryllium. So 1s2, 2s2. Okay, so here's beryllium, and then it's going to have 1, 2, 3, 4 electrons in the 2p. Okay. Let's do a couple more that are even further on the periodic table. Let's try phosphorus. Phosphorus is number 15, so I've got to have 15 electrons total. So we're going to start with 1s2 and then 2s2, just like always. Every single element is going to start with these same ones. And then we're going to have 2p6, all 6 electrons in the 2p. Then we're going to go over here to 3s2. And then all the way to 3p3. Okay, we're going to do one more long one. Gallium. Gallium's number 31, so it's going to take a second. We got to account for 31 electrons. So it's going to have all the same ones as phosphorus before it. So 1s2, 2s2, 2p6, 3s2, 3p6 this time. So we're going all the way to argon. And then 4s2. Okay, and now something weird happens with the D sublevels, and you're going to want to like label a periodic table with this. This fourth row is 4s, but then it goes to 3d, and it just turns out that the 3d room is actually higher in energy than the 4s. So I kind of drew my hotel wrong. This 3d should actually like be up here between 4s and 4p, but I didn't want to confuse you. So you just follow the order. So 4s2, 3d10, and then gallium's right here. So 4p1. Okay, so that's the electron configuration for gallium. Now, that takes a really long time. So there's actually a way that we can abbreviate it called the abbreviated electron configuration. Okay, so instead of having to write all of this, the way you do an abbreviated electron configuration is you put the previous noble gas, I'll explain what those are in a second, in brackets. Then do the rest of the configuration. Okay, so the noble gases are this last column right here. So like helium, neon, argon, krypton, they're called noble gases because they don't react with other elements. You might know that already. But let's do phosphorus the abbreviated way. So instead of writing all of this stuff, we find phosphorus, we find the noble gas that comes before it, which would be neon, and we just put neon in brackets, and that basically means the whole electron configuration of neon, and then we just need to do stuff past neon. So neon, 3s2, 3p3. Okay, so this means the same thing as this. We just didn't have to write it all out. Let's do gallium. So gallium's right here. Noble gas before gallium is argon. So we do argon in brackets, and then it's going to be 4s2, 3d10, 4p1. Okay. And yeah, that's how you do electron configurations. There is an assignment on Canvas that you will need to do. And if it doesn't say to do the abbreviated configuration, just do the like long version. I know that's like kind of a pain, but you just want to do that. That will make it easier. And then on Canvas, let me actually show you what it's going to look like. Just a second. So your assignment is going to say like, right, the electron configuration for chlorine. And so chlorine is number 17. So it's going to be 1s2. And then you need to have a space. And then it would be 2s2, 2p6, 3s2, 3p5. So 2s2, 2p6, 3s2, 3p5 is what you would do. So that's what your assignment's going to be like. And then it'll ask you questions like, what sublevel fills after 5s? So you look, there's 5s, and then after it is going to be 4d. So again, you're going to want to get a periodic table that's labeled like this. I'll post a picture of one. That will be helpful. Just FYI, the F sublevels are like 2 off from where the S's are. So the F's go in right here. It goes 6S, 4F, 5D, and then back up to 6P. I know it's confusing. I know a lot of this is really abstract, and I know this was a super long video. Good job for getting all the way through it. I hope you guys all get all the way through it. If you have questions, please send me an email. And I will set up a Zoom meeting with you or something, and we can talk through this. Again, like I said, this is really abstract, but there is a logic to it if you practice. So just do your best, practice. Let me know if you have any questions. Good luck.